Now the other case is when you've got your odd power on your sine x. If that's the case, then you're going to split off one factor of sine x, and that's going to be part of your du. And then you're going to use sine squared is 1 minus cosine squared to write everything else in terms of cosine x, and then you let u equal cosine x. So let's look at an example. Integral sine cubed 4x cosine to the 3/2 power 4x dx. So I see an odd power on that sine, so that's the one that I'm going to break off to be part of my du. However, these are sine and cosine of 4x, so I'm going to do a simplifying substitution here first. Let's use a different variable. Let's call it w. So let's let w equal 4x. Then dw is going to be 4 dx. And so I'm going to multiply by 4 right here, and then 1/4 on the outside to compensate. So right here is my dw. And so this will now be 1/4 integral sine cubed, and then 4x is w, and then cosine 3/2 w, and then 4 dx, that's my dw. So simplifying, use substitution first. So now we got 3 factors of sine. We're going to break one of those off to be the du. So this will be 1/4 on the outside, integral sine squared w. And I'll leave a little space, and then we'll put that other factor of sine w out on the end, sine w dw, because you can multiply in any order. And then we got cosine 3/2 w. So this is going to be our du, and then u is going to be cosine. It's almost our du. It's part of our du. So we need to write everything in terms of cosine, in particular our sine squared right here. That's 1 minus cosine squared of w. So let's go ahead and get our u substitution going. So our u is going to be cosine right there. So u is going to be cosine of w. And then our du, derivative cosine is negative sine w dw. And we've got the sine w dw. Let's multiply by a -1 inside and outside to compensate. Double negative is equivalent to the positive. So our du actually includes that minus sign. So now we got a -1/4 out in front, and this will be integral 1 minus cosine squared, which is 1 minus u squared. And then cosine 3/2 w. So that's cosine w to the 3/2. So that's u to the 3/2 power. And then here's our du, negative sine w dw. So now we'll just multiply that u to the 3/2 in, and then it'll be power rule again. So you got a -1/4 out in front. Let's see here, integral u to the 3/2 times 1, u to the 3/2. And u to the 3/2 times u squared, you're going to add those. So this is 4/2 and 3/2, 7/2. So minus u to the 7/2. And then we've got du out on the end. So now we can integrate that. That's just power rule, right? So you got a -1/4 out in front. Antiderivative u to the 3/2 is u to the 5/2, right? Add 1 or 2/2 to the exponent. Divide by 5/2, which is multiply by 2/5. Minus antiderivative u to the 7/2. We add 1 to the exponent, so add 2/2 to the exponent. That'll be u to the 9/2. Divide by 9/2 is multiply by 2/9. Close up our parentheses, and then plus c on the end because it's an indefinite integral. Okay, and we're almost there. So our u here is cosine of w. So we need to plug that back in. So we got negative 1/4. And then, well, we could go ahead and multiply our negative 1/4 in at the same time. So negative 1/4 times 2/5. So let's see here. This 2 will cancel into the 4 and leave a 2 down here. So that'll be what? 10 on the bottom, negative 1/10. And then u to the 5/2. U is cosine of w. So that's going to be cosine 5/2 w. Negative 1/4 times negative 2/9 will be positive. This 2 will cancel into the 4 and leave a 2 down there, times 9, 18. So 1/18. And then u to the 9/2 will be cosine w 9/2. So cosine 9/2 power of w plus constant. And now we just have to plug back in our w is 4x, and we got it. So negative 1/10 cosine 5/2 of 4x plus 1/18 cosine 9/2 of 4x and plus our constant. And now we got it. So that one was a little bit more work. Use substitution in addition to breaking off powers. Plus we had some fractional exponents in there.